Why you always in the mood? Mess around acting brand new. I ain't tryna tell you what to do, but try to play it cool. Baby, I ain't playing by your rules. Everything look better with a view.
Hi, my name is Nur Hannani binti Muhammad Asri and my matrix number is 2020-824398.
Assalamualaikum. My name is Muhammad Hazidania bin Baidul Hisham and my matrix number is 2020-863774.
Assalamualaikum warahmatullahi wabarakatuh. My name is Cikgu Rasaila binti Cikgu Ramli and my student ID is 2020817796.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahidini Azrik bin Muhammad Sufyan and my student ID is 2020488252.
Differentiation is a process of finding the derivative or the rate of change of a fx, which is a function with respect to x. Basically, in general, it is used to measure the change in one variable with respect per unit change in another variable. It is also can be used to determine whether a function is increasing or decreasing. One of the massive use of differentiation in math is to find the maximum or minimum values of a formula such as area and volume. In calculus, you'll find the functions on which you want to determine the maximum or minimum values as the common application problems. In order to solve the problems, obviously, you'll need to use differentiation. In this video, we are going to be showing you one of the examples of the application problem and how to solve it. We will also have a conclusion to summarize the whole video. To make all of this possible, we've done few researches and the references we have preferred will be stated at the end of this video. So without further ado, let's jump straight into it.
Now, let's talk about problem statement. Take a look to the diagram. This diagram shows a closed cylinder which has a radius of r and height of h in centimeter. The volume of this cylinder is 1200 pi centimeter cube. The material for the top and bottom will cost 2 ringgit Malaysia per centimeter square, while for the side will cost 3 ringgit Malaysia per centimeter square. Now, we want to find the total cost of the cylinder in terms of radius. Last but not least, we'll also want to know how much the minimum cost to construct this cylinder. How we gonna solve this problem? Don't worry, Cikgu Rosuhaila will help us.
Okay, thank you Haziq for reading the question. Now our Cikgu Rasaila binti Cikgu Ramli will continue to answer the question. Question A. We want to find the total cost of the cylinder. The information given: top and bottom costs are N2 per cm square and material size costs are N3 per cm square. So the equation must be in formula surface area cylinder because it's cm. But first we must label the quantities relevant to the problem. The information I give V equal to 1200 pi cm cube. Here we can find the quantity that relevant to our problem. Volume of cylinder is pi r square h, so we equal it to 1200 pi and we can get h equal to 1200 per r square. And then we want the total cost is in surface area cylinder formula. So A equal to 2 pi r square plus 2 pi r h. So h here we can substitute this h into the equation. And then we calculate it and we got 2 pi r square plus 2400 pi per r. And then total cost C equal to 2 pi r square multiplied by 2. Why? Because the top and bottom cost 2 ringgit per cm square. Then this formula is formula of circle, the top and the bottom. And this is the formula of measure size. So the top and bottom must multiply by 2 and the sides must multiply by 3. So we got the equation 4 pi r square plus 7,200 pi per r. So this is final. So we find the total cost in an equation. Next question B. We want to find the minimum cost of constructing the cylinder. Okay, as we got earlier, C equal to 4 pi r square plus 7,200 pi per r, right? So we must derivative it. And we got 8 pi r minus 7,200 pi per r square. And we must let dc dr equal to 0. So with this, we can find the r. So we substitute dc dr here equal to 0. And we calculate it. We multiply the r. We got r cube here. And the 8 pi, we move to the right side. And we calculate here. And we got r equal to 9.65. After we got the r, we can get the h2. H just now is h equal to 1,200 per r square, right? So we substitute r here into this equation and we got h equal to 12.89. So we can get the cost of the cylinder. C equal to the total cost is equal to this equation, right? 4 pi r square plus 7,200 pi per r. And we substitute r here, in here. So we got r and 3,514.20 cents. But we must prove the cost is minimum value. So we use second derivative. So this is first derivative. Our first derivative. So we must get second derivative. So equal to 8 pi plus 14,400 pi per r cube. And then we substitute r into the equation. We got this, right? And we got it 75.505, which is bigger than 0, which is it means it's minimum. So the cost is minimum. So that's I have answered all the questions. So thank you. That's all from me.
In nutshell, we can conclude that maximum and minimum problem solving is very important in our life. For example, we can use this calculation to find the minimum cost to construct the cylinder beverage cans. The factory can save their cost to construct the cans in large numbers every day. Other than that, we can use this calculation to find the minimum cost to construct the bricks. Bricks are important in our life because we can build many things with it, such as houses, walls, and malls. Last but not least, we give our thanks to our lecturer, Madam Nolaila, for providing us this opportunity and for giving us lots of help while completing this group assignment.
ありがとうございました。
I got my mind on survival, steady with my rival. Target dapat kuya, number one on my title. Yeah. I got my mind on survival, steady with my rival. Target dapat kuya, number one on my title. I got my mind on survival. steady with my rival. Yeah, target dapat kuya ng